Hello everyone, in this video I'm going to go over the multiplier. As you know, we have already covered the multiplier in chapter 10, and the main equation or the main model was basically the aggregate expenditure equal to the autonomous part of the consumption plus the MPC, the margin propensity to consume, times income plus the autonomous investment plus government spending plus net exports. So we had this equation from chapter 10, and this part was basically the consumption, the part that is autonomous and the part that is induced, that depends on income. The assumption was that other parts of aggregate spending are basically autonomous. So out of this model, we were able to derive the multiplier, right? And we have this big assumption that whatever this economy is spending is equal to the total income, okay? And accordingly, we were able to solve for y by saying that y minus MPC y is equal to C bar I G net exports. And if you take y as a common factor, then 1 minus MPC, which is basically MPS, is equal to C plus I plus G plus net exports. And then we ended this equation by saying that it's 1 over 1 minus MPC. I keep writing it in capital. It doesn't matter. Just I prefer to write it in small letter. This whole thing times C plus I plus G plus net exports. Okay, and this is the part that is called the multiplier. So anytime I have a change in any of these autonomous spending would be reflected in y, right? But any change here, or any dollar change here, or any yuan unit change in any of these components would have to be multiplied times 1 over 1 minus MPC to get the change in y. And given that this MPC is less than 1, then this whole term would be greater than 1. So a dollar change here would give me more than a dollar increase in y, because every single person will keep spending the income, and the income of one person would be the spending of another, and so on. So the $1 would keep circulating in the economy to make the dollar increase in any of these components would result in more than a dollar increase in output, or y. So we can write it actually like this. We can say that the change in y is equal to 1 over 1 minus MPC change in any of these components. Let's say if I choose autonomous spending, for example, or any other change. So you will be given, as we had in chapter 10, you will be given a change in one of the components. Doesn't have to be I or investment, it could be any other thing, and multiply times the multiplier would give us the change in y. Okay? In chapter 13, which is the current chapter, we're just making this model, or we are expanding this model to allow for taxes. So we have what we call the tax multiplier. And the main difference here is that instead of just saying that the person is going to, or consumption of a certain person is equal to the autonomous part that does not depend on income, plus the part that depends on a fraction of income, which is MPC out of income. Instead of saying that it's just income, we have to be kind of more specific here and say It's not just income, but it's income after I pay taxes. So instead of having it as Y, we're going to replace it as what we call disposable income. So disposable income is simply all the income I earn minus the part of my income. Okay, so this was supposed to be T. Okay, so it's the part of my income, which is just a fraction. So small t is just a fraction of my income that is going to taxes. Or we can take just as a common factor y, so it's 1 minus t is whatever is left over after I pay taxes, which is what we call disposable income. Okay, so for example, t could be, let's say, 10% out of my income is going to taxes, or let's say 0.10. So it's a fraction out of the 1. So this thing, we have to go back to our equation, and every time we see y, it has to be replaced by yd. Okay, so our model would look like this. So our model would look like this. So we have the aggregate expenditure is equal to the consumption plus the MPC, but multiplied times 1 minus small t y plus I plus G plus net exports. And again, we do the same thing. We take the assumption that aggregate spending in the economy would be equal to total output, or total income. Accordingly, we can solve for y in this equation. And again, once we solve for y, so we can say that y is equal to 1 over 1 minus t times MPC. This is the new multiplier if I allow for taxes. And everything is multiplied times the same autonomous variables, right, that we had in the previous slide. This is called tax multiplier. Okay, and as you can imagine, if this t is equal to 0, then we go back to the main formula for the multiplier, or it's going to be 1 over 1 minus MPC that I had in the previous slide. Okay, so the presence of this tax multiplier basically means that a $1 increase in any of these autonomous spending would have less impact on y in the presence of t, right? So mathematically, when you look at t here, it has a negative sign and it has another negative sign outside the bracket, and it's in the denominator, so that implies that it will reduce the multiplier as compared to the main formula for the income multiplier, spending or expenditure multiplier, I should say. So if we apply these with numbers, you have a good example on your textbook. So mainly you have to be given some information to be able to answer this question. So if you have, let's say, MPC is equal to 0.8, and if you have the fraction out of your income is 15% going to taxes, right? Then that means in order to be able to determine the tax multiplier, then you're going to find tax multiplier as being 1 over 1 minus 0.15 times 0.8. This will give you 1 over 1 minus 0.68, which means 1 over 0.32, or the tax multiplier is equal to 3.125. Okay, so the tax multiplier is equal to 3.125. So that means if I'm looking for a change in Y because of a change in one of the autonomous spending, investment or government spending, or any other factor, let's take government spending, for example. So that means the change in Y because of the change in the autonomous spending in government expenditure would be 3.125. A $1 increase here would imply about 3 times increase in Y. Okay, so you have also another example in your textbook in page 485. You can check it if you have the textbook, or actually you can check it on your ebook.